In this section, we learn about linearization and differentials. We have several problems to do. So the first one, find the linearization of f of x equal to 2x squared at x equals 1. So the linearization of a function about a point x naught is L of x is equal to f at x naught plus f prime at x naught times x minus x naught. So our function f of x is 2x squared. So we need f prime of x, that's 4x. So now we need f at x naught, which is f of 1, is 2, and we need f prime of 1, that is 4. So now we get L of x is going to equal f of x naught, which is 2, plus f prime of x naught, which is 4, times x minus x naught, which is 1. So this f of x then is approximately L of x, which is 2 plus 4 times x minus 1 when x is near 1. Problem number 2. We need to find the linearization of f of x equal to the sine of x at x equals 0. So f of x is the sine of x, and f prime of x is the cosine of x. F of 0 is 0, and f prime of 0 is 1. So L of x is equal to f of x naught, which is 0, plus f prime, which is 1, times x minus 0. So that is equal to x. So therefore, f of x, which is the sine of x, is approximately x when x is near 0. Okay, number 3, find the linearization of f of x equal cosine x about x equals pi. So f of x is cosine x. F prime of x is minus the sine of x. F of pi is equal to -1, and f prime of pi is 0. So L of x is going to equal -1 plus 0 times x minus pi. So therefore, f of x equal to the cosine of x is approximately -1 when x is near pi. Okay, so that completes our linearization problems. Now we want to find the differentials. So f of x is equal to the cosine of x, and f prime of x is minus the sine of x. So therefore, the differential df is equal to minus the sine of x dx. So here we have f of x is equal to 6x cubed. So df dx is equal to 18x squared. So that applies then that df is going to be 18x squared dx. And then number 6, f of x is 5x to the 4th minus 3 times the sine of x. So df dx is 20x cubed minus 3 the cosine of x. So therefore the differential df is going to be parentheses 20x cubed minus 3 cosine x dx. So that's the differential. Now on to some word problems. By how much does the area of a pizza change when the radius is decreased from 14 inches to 13.5 inches? So first thing is I like to draw a picture just so I know what I'm working with. So I'm talking about a pizza. A pizza is a round circular object that has a radius r. And I need a formula. So they're asking me about the area of the pizza. So they want to know how much does it change? Well, we can figure out that if we know A at some R, and this is known, then A of R plus delta R is the unknown. And so the change is if you take A of R plus delta R and subtract A of R, that gives you the change in the area. But that would also mean that I would have to find this term in order to compute this term. So we use the differential. We say that df is approximately delta A. And what is df? Well, df is going to be A prime at R dr, where dr is our small change in the radius. So therefore, we need the formula A of R. So A of R is pi r squared. So now we have a formula to help represent our situation. Okay, and so our dA is going to be A prime of R dr, and A prime of R is simply 2 pi r. So therefore dA becomes 2 pi times r times dr, again dr being our small change. So therefore, our radius is originally 14 inches. Our new radius, r plus delta r, is 13.5 inches. So that implies that our delta r is minus 0.5. So therefore, remember, dr is equal to delta r. So there we have it, the new area, the change, dA, is going to be 2 pi times r, which is 14, times a negative 0.5. This is the dr. So that's going to be, our change is going to be negative, because it's negative, 14 pi. And then our original thing is in inches. So this will be inches squared. Okay, next problem. Italianate ice is put into a paper cone with a radius of 3.1 inches and a height of 5 inches. Approximate the volume of the ice. So here's our ice cream cone. It has a radius of 3.1. And it has a height of 5 inches. And the problem asks us to approximate the volume of this cone. Okay, so first off, we need the volume of the cone. So the volume of a cone, we drew our picture. So now we need a formula. So the volume is 1/3 pi r squared times h. And if our cone had radius 3, this would be easy. But it's 3.1, so we have to put 3.1 in and try to figure that out. So we want to just approximate it and not get an exact value. So we know that the volume of R plus delta R is equal to the volume of R plus V prime at R times change in R. Okay, so this piece, we're going to use the differential. So we're going to use V prime at R dr. So what would our R be? So our R would be 3, because that's a very easy known value. And R plus delta R, this is what we're working with, would be 3.1. So that implies that delta R equal to dr is equal to 0.1. Okay, so the value we're trying to find is this. So we're going to need V at 3. So our answer is V at 3.1 is V at 3 plus V prime at 3 times 0.1. So now we need V prime at 3. So we're doing V prime at R. Remember now, here in this problem, H is fixed. The only thing that's changing is R. So H is fixed, not changing. So our volume is actually, let me just rewrite that. 5/3 pi r squared, because h doesn't change. It's always 5. So v prime at r becomes 10/3 pi times r. Okay, so v at 3 is 5/3 pi, and 3 squared is 9. So that's just 15 pi. And then v prime at r is 10/3 pi times 3, which is 10 pi. So therefore, v at 3.1 is 15 pi plus 10 pi times 0.1, which is 15 pi plus pi is 16 pi.